Live from New York, it's Ask These Engineers.
Hey everybody, and welcome to Ask Engineer. It's our weekly engineering fun show. It's me, Lady Ada. With me is Mr. Lady Ada. We're here at the Adafruit factory where we do all of our design, and engineering, and part specification, and tutorials, and manufacturing, and shipping, all that good stuff. And as a special Ask Engineer Day, we have 2 engineers for you. Yes, double the money. Not only do you get me, the engineer, we also get Judith Hensel.
Hi everyone.
Hi, you're an engineer at TE.
Yeah, I am.
And we're going to be talking all about TE sensors and the contests and stuff and giveaways and stuff that we've been doing and the show and tells that we had. We've got a really exciting show.
Big show.
Whew.
Okay, want to do this?
Yeah, what's on tonight's show?
On tonight's show, the code is TED-DigiKey. No, TE-DigiKey. 10% off, and Adafruits are all the way up to 11:59 p.m. Eastern Time, everything except for AdaBox and gift certificates. It supports us, an open source hardware company. Yay, here's some of us here. And before I forget, special shout out to everyone at TE. Thank you. They stopped by today. We're going to go over the show and tell. We have lots of things. We're going to play some of the videos from the TE-DigiKey My Mini Race Car Show and Tell, and we'll talk about some of the show and tell that was on there. Packing mailbag didn't stop by, some time travel, some made in New York factory footage, got a little bit of Adafruit I/O news, some 3D printing, new products. We'll answer your questions. We'll have a trivia question. We're going to give away something really cool. All that and more on Ask an Engineer. We might not get to some of these things, but we're going to try.
Do the best we can.
We're going to do the best we can.
Yeah.
Okay, so let me just go through a couple show stuff, and then y'all can take it away.
Yeah.
Got to pay some bills.
Do this thing.
Yeah, all right. You're watching Ask an Engineer, 8 p.m. every Wednesday. We just did show and tell. 7:30 every Wednesday. For all y'all who like the Discord chat, it's this like thing that all the folks who like to do gaming, we have one now.
It's like IRC.
Yeah, so it's I made a short URL, adafruit.it/discord, and we have a chat room, cool code of conduct, so it's family friendly and all that stuff. We have moderators, but be excellent to everyone in this chat room. We can keep it pretty cool. So that's the Discord chat. Next up. Same-day delivery, check out by 11 a.m. in New York City. If your zip code is in the list when you check out, you can get same-day delivery. Just make sure you check out before 11 a.m. Free UPS ground, $200 or more in the continental USA. We added DHL, yay, to Canada. We also added DHL to UK, France, Germany, and I think we've added a few more.
Yeah,
so,
we're adding more of Europe.
Yeah, so it's neat because on checkout, all the customs and prepaid everything.
Tariffs, VAT, everything, yeah.
It just literally flies right in.
No surprises.
Yeah, no surprises. Okay, and then also we have our free stuff that we're doing. If you have an Adafruit account, you get a different pin for $99 or more when you spend $99 or more. And we keep track of which pin you had, so you get a different one. And of course, if you use a guest account, we just send you a random one. Okay, all right. Our guest tonight, Judith. Oh, Judith.
That's you.
And,
that's me.
Yeah, and you have all these neat things on the TE site and some of the things. Can you tell us a little bit about TE and what you do?
Yeah, I'm working for TE Connectivity since more than 3 years now. So TE Connectivity is a huge and worldwide company which is working with whole solutions, like for transportation solutions and
transportation
connections,
roads,
connectors, sensors, and also some different kind of business units. So we have like ICT, with just like solutions within like trucks and so on. So in huge stuff. Also automotive. We have like medical care and medical stuff as well, and also aerospace and defense. Yeah, like
and like Internet of Things. I saw that on the list. You kind of cover everything, and then we have TE sensors that we have the board that we have for the My Mini Race Car. I thought this was neat. So we're always interested in companies because Adafruit keeps growing. So 12 billion in sales. And 7,000 engineers. Yeah,
7,000 engineers worldwide and 75,000 employees all over the world.
Wow.
Yeah,
it's a global
huge company.
Where did TE start? Is it like, did it start in Europe or the US? Do you know where it was?
I think it started somehow in different smaller companies, and it grew.
That's what eventually happens. Companies kind of come together as they compete in the marketplace are like, we like you, and they get bigger.
And so TE does mechanical engineering, so like connectors and specification, and also electrical engineering.
It's more electrical engineering.
Oh, yeah?
So I studied mechanical engineering, but it's more electrical engineering. So that's like TE started. Yeah.
Okay.
Okay. Next question. So you're also doing stuff with Andretti Technologies. How did that come about, and what is that all about?
That's about like Andretti Technologies is within the Formula E series, and the Formula E series is a pretty young series. It's in the 3rd season now, and the special thing is they have like whole electric cars.
Yeah.
And our TE connectivity is standing for sustainability and green energy, and for building up the future. And like whole electric cars is the future of transportation, and that's why we choose to have like a connection with Andretti Technologies.
Yeah, that's neat, because a lot of people will see the value of electric cars on the racetrack, and they'll be like, next time I purchase a car, maybe I'll consider an electric vehicle.
Yeah, right.
But also like the technologies that get designed, like the sensors and the battery management, you know, whatever people are making in the race cars, it's always going to be like the tip of
the
whatever.
iceberg.
Whatever, it's like you just have to have it work for 10 minutes, right? So it's going to be like the best, and then that technology will eventually trickle down. Just like sensors, you know, I like to tell people when I first started doing electrical engineering, an accelerometer was $20 and it was 1 axis. If you wanted 3 axis, you'd have to get 3 and you would mount them in different orientations, and then you'd have to calibrate them.
Yeah.
And now you can get a triple axis accelerometer for like $1. It's so inexpensive. So what started as like aerospace or like racing or like industrial is now in every phone.
Yep,
And
exactly.
I just read like in Europe in 2040 there's only going to be electric cars are going to like they're thinking about making it so you can only buy electric cars. The battery management, the power management, the connectors, gas technology we've had for like, you know, many years, 100 years. So we kind of like know what it takes to build a combustion engine, but I think we're still learning how to make the best out of a motor that is a fully electric car.
Yeah, exactly.
But you're there. You get to build it.
Yeah.
That's cool.
Okay, and then on the TE Connectivity YouTube channel, there's a bunch of really good videos. I'm going to play some of them later. One, TE is one of the few billion-dollar companies that I know of that celebrates women in technology, women doing engineering.
Yeah,
and
exactly.
they have some videos of you, and then I'll play at the end, which is really neat, because there's in our world of, I'd say mostly like the Googles and the Oracles and like, not really Uber, but they're a technology company. And we heard about the problems in Silicon Valley and women going into those industries. There's no videos, there's no pictures of the people that work there. And I think that what TE is doing is really good, because a lot of, especially young girls, can imagine themselves working at a place like this.
Exactly, and it's inspiring young girls to study something in STEM and to be creative, and
Yeah. I didn't want to put this in the show, but because I did all my TE research a while ago. So TE did this thing. It was 4 girls, 4 days, and it was the world record for electric car, the longest distance, I think.
Oh, neat.
It was in Europe, and it was they went as far as possible in like 4 days. 4 lady drivers, and
exactly.
It was super cool. And I think it's like, I could post a URL later. But that's really neat. You don't see a lot of companies do that. So whoever, if you have a suggestion box at work, just say,
that's cool. We have something like this.
Yeah, so that was really neat, and folks should check that out. So here's some videos that kind of tells your story and some of the things that you're up to.
Yeah, exactly.
So,
okay.
Take it away.
Take it away, you.
Judith,
a month ago.
In Germany, when I was a small kid, I was so interested in cars and kind of engineering technical stuff. I never ever think that I had the chance to be a part of a Formula electric racing team. I'm traveling around with the team to all the Formula E races. When the cars arrive, you need to assemble the cars again, and then they are checking like the car is fine. The data we are receiving on the computer is like constantly checking the system. We can say exactly how the driver should behave in this corner, how hard he shall push on the throttle, or how sensitive he shall be with braking at a certain point. I'm also having a look at the products which are going into the test car, and that they are doing what they shall do in this car. This partnership, from TE connectivity and Andretti is really important for the future transportation because it's a whole electric car. So it's all about having green and sustainability. So this is really the future we are trying to build up together. TE definitely encourages women to do what you love. They always encouraged me to do what I want to do, and now I have the great opportunity to be at the Andretti shop and work together with the whole racing team. Within TE connectivity now, I had a mentor. His knowledge is brilliant and inspired me. It is really important to have a person on your side who is explaining what's going on when you're new in a company. The work environment within TE, I really love it. Did not ever had a problem working in a male-dominated field, you know, and it's not like I'm feeling, oh, I'm a woman. I'm an engineer. I'm not different compared to these guys. I would tell like little girls who wants to get into STEM, just do it. They should not listen to anyone who is telling them, you are not meant to do this. You are a girl. Do what you love and do it with passion. TE definitely encourages women. They always encouraged me to do what I want to do, and now I have the great opportunity to be at the Andretti shop and work together with the whole racing team. The work environment within TE, I really love it. Did not ever had a problem working in a male-dominated field, you know. I'm an engineer. I'm not different compared to these guys. I would tell
That's exciting.
So I grabbed the longer clip and then I got the shorter clip, so I emphasized the message.
But there's more of you.
Repetition.
Okay.
That's
Totally fine. I like that they can supercut. They can just take the highlights.
Okay.
All right, so y'all just did a show and tell.
Yes.
Do you want to talk about what's on
Yes. Well, yeah. Do you want to talk about some of the robots as well?
Yeah, let's do the show and tell that we did at 7:30.
Yeah.
And then we'll play the show and tells that folks sent in.
Oh yeah, of course.
Yeah.
Okay, so for our 7:30 show and tell, which is a classic show and tell, we had Scott from Adafruit, who's been working on CircuitPython, and he is building a hardware continuous integration setup. So all the boards and the software, you write code, and then you have to test the code on the hardware, but then you made a mistake in your code, and then the hardware seems like it doesn't work, but it's really the software. I'm sure that's never happened to you. And so now he has a system where the Raspberry Pi, and it actually sends the software to the hardware and then checks that the hardware works, which is really neat. So it'll let him code and not have to worry, like, did I just break some other hardware system by updating the Python core. And then Phil B released a guide on NeoPixel DMA. Check that out if you want to do NeoPixels with DMA. So you can do that without using your microcontroller cycles that are so precious. Bill Binko from AT Makers built a head turner that's 3D printed with ball bearings, and he's trying to figure out how to make it maybe less turny. It's really turny. And then Chris Young came by. Chris Young's birthday was today, so happy birthday, Chris Young. We all sang happy birthday. It was terrible, but wonderful. And he lives near Andretti Motorsports. He says he used to drive by there, so it's kind of neat.
Yeah, our holiday album will be coming out soon.
Oh yeah, we're gonna sing.
Yeah.
Happy birthday.
Show and tells.
And he also has a guide, an infrared receive guide for Circuit Playground. So check that out if you're interested in using infrared sensors, receiving and transmitting. There's a new guide. Hazel and her dad showed up. Hazel made a 3D printed bowls. Last week she just learned how to do 3D printing. Now she's already like making bowls with like text etched into it.
Pretty cool.
She made it for Father's Day. You know what's really funny is, you know, when like we were kids, you would make an ashtray. But like that's like, you shouldn't make an ashtray for your dad because you should probably not smoke. Yeah. So now you can make bowls instead, but like not ashtray. You can like, you know, maybe eating bowls or something. I don't know. Yeah. Adam M has a scanning electron microscope update. He got some relays that were charred. He's replacing them. He's repairing the wire. He also needs much thicker cables because he needs like 10 amps to run the electron microscope, and he's using an extension cord. But the extension cord, the wires are too thin. So he got some like really thick 8-gauge wires, and he's going to bury them underground in some conduit, and he's working on that, so he's a shovel. So this is the shovel and tell, I guess. And then Stuart is in Florida, and he has a water softener that uses salt to get the lime out of the salt. And he put a sonar. Everything in his house is completely electronically updated. He just loves doing that. So this one has a sonar, and it looks for the salt level. And when the salt, I guess it comes out the bottom, when it goes too low, it'll blink and yell and tell him to replace the salt. So he's got a cyber home, so that's Stuart. And he's heard of Inverness, Florida.
Yeah, I know, no one has. Okay.
He has.
All participants on the show and tell get, and as seen on the show and tell sticker. Let's play some videos from...
Yes, we had a special edition show and tell at 6:30.
Yeah, let's do that.
For My Mini Race Car, we have some videos that came in.
Yep.
Do you want to play those?
I'm going to play those.
Why don't you play those?
I'm going to see what's going on.
Yeah?
Yeah,
Okay.
I can do that.
Let's do it.
Okay, for show and tell, I wanted to bring my new iteration of the My Mini Race Car kit. The previous version I had done used the Bluetooth capability so that I could control the car from the app on the iPad, as well as stream the data about temperature and humidity. This time I did what I had threatened to do before, which was control the car using humidity. So I've just updated the software and I'm checking my serial port for humidity readings, and I'm getting readings around 55 at a peak. So now with the humidity and temperature sensor here on the back, if I go ahead and blow on it, I should go over that value, and that's when the motors will engage. Okay, that could make for a pretty interesting race. That is my show and tell of the Formula E My Mini Race Car kit using the TE connectivity humidity sensor and the little 3D printed parts on top of our My Mini Race Car kit.
Hey friends at Adafruit, I am Kevin from DigiKey, and I was challenged to share with you some of the modifications I did to My Mini Race Car. My Mini Race Car is a joint collaboration between TE Connectivity, Adafruit, and DigiKey. We encourage everybody to buy this kit and do any kind of modifications they can to it and share it on Twitter with the hashtag MyMiniRaceCar. These things can go really fast and get a little hairy on the hairpin turns, so be careful. Some of the modifications I did is I added the circuit playground to the wheels. We always like the bling on the wheels. So as you turn the wheels, the accelerometer will change the color of the NeoPixel LEDs. John Park created these great 3D printed fairings. And I used his design, and it's the same exact design. I just scaled it down a little bit because his design, this was his original size. It's a little bit big, and when I'm going fast in this race car, I love driving this thing around, but I want to be as fast as I can. So these fairings I wanted to line up with the actual wheels to reduce the drag. Another thing I did is the TE humidity and temperature sensor I put on the back of the car, so as I'm passing my competitors, I want to be able to see how angry they are because their faces are going to get red and they're going to get hot. So that's why it's on the back of the car. Another thing I added was the roll bar. This thing, like I said, around hairpin corners, this can get a little tricky. So I want to make sure and protect myself when driving this thing. The really cool thing about this is Adafruit created the Bluefruit app for your iPhone or Android, so you can drive this directly from your phone. But one other thing is you can actually drive it from your watch. Let me pull up the app here and see if everything's connected right. There it is. So now, you guys gonna come with me? Yeah. Let's do this. Got my car.
Hi guys, I'm Tristis. I'm an engineer at DigiKey Electronics, and I wanted to present to you my modifications for the My Mini Race Car. So I'm a very big fan of race cars, and specifically street racing. So I wanted to give My Mini Race Car a kind of a street race car kind of look. So in order to do that, I actually added 3 16 NeoPixels and it's actually all powered by the Gemma, which is powered by the 3.7 lithium ion battery. So in order to kind of test this out and show you, so the LEDs, and there's an LED at the bottom, and it actually gives it that kind of the underbody look of a street race car. So in order to actually mount my Gemmas, I actually found USB cases, like the cover for the USB, and kind of broke it off and just bent it to the side. And it actually is hovering over the wheel. So I don't actually hurt the wheel in any type of way. And it's really cool because you can actually just unscrew it and take it off. Pretty simple. And let's give it a whirl. But anyway, I encourage everyone to actually come pick up one of these My Mini race cars. It's really cool. And show us what your modifications look like. What else cool can you guys come up with?
So this is the one that we showed. These are just screenshots. This is from Adafruit.io.
Yep, this is an update to the guide that Tyler did, and this is code that allows you to use a Wi-Fi microcontroller so you can internet connect and sense instead of having to use Bluetooth. So if you're interested in like sending your data like across the country instead of just a block away, check out the Wi-Fi update. You can also log the data, store it for analysis later.
Yeah, and I have a screenshot of some of the TI stuff, sorry, TE stuff, I was TE stuff, valves. And you kind of do some of that now. There's always sensor data getting transmitted from the cars, right? Like,
yeah, exactly.
You have to.
And sure, that's the sense of sensors, that you're getting data out of them and that you can use the data to be more secure in the end and to be sure what is going on there.
So during the race, the pit can get telemetry?
Pedal position,
most of the time,
speed, like all this stuff.
Most of the time, it's really kind of limited data you get during a race, but after the race, they're sitting together like the whole bunch of engineers and discussing what was going on, what was good, what was bad, even with the drivers.
Yeah.
So it's like a huge round sitting there on the table and discussing what was going on during the race, which was not obvious at this time.
Yeah, I saw there was a T video that I was watching, and it's like millions of engineering hours for milliseconds off the time.
Yeah.
That's what it turns into.
Yeah,
you
exactly.
Have to do that, because that's what it comes down to in the end. It's just like a millisecond. So how can you get better data to make the car go a little bit faster?
Yeah.
A little bit faster. Okay.
So this is the plot that you get afterwards, that you can download it from the car, or is that? Do you think is it a live one?
No, that's what you get afterwards, and you can go really into detail into every single graph you have there, and into milliseconds.
And what's nice is it's all together. You can say you're like, oh, why did the torque drop? And then you're like, oh wait, the battery temperature spiked because something happened.
Exactly.
Okay, so that's like you can do correlation. You can figure out if something is wrong, and then. Before the race, do they get to practice on the racetrack so you can see what the data would be like?
You have mostly you have a shakedown before the actual race day. So this is on a Friday. Every driver has 2 cars because they are doing a car swap during the race.
What's up with that? Why do you have to do that?
Because the capacity of the battery is only 28 kilowatt hours, and this is only lasting for up to 50 kilometers.
Okay.
And then the race would only take 25 to 30 minutes.
Okay.
So as the capacity is not increased so far, but it will be within season 5, the plan is to have the capacity up to 54 kilowatt hours. Then there is no car swap needed anymore.
And why is the capacity limited? Is it literally the technology, they cannot make the batteries, or is it they just decided, hey, we're going to cap it at this for now?
It's the technology so far, and the battery is already up to 350 to 400 kilograms, and this is half the weight of the car.
Wow.
So the car has a total weight of 880 kilograms, including the driver.
And what kind of battery is it? Is it like a lead acid, a lithium polymer?
It's a lithium-ion battery, and it has a separate cooling system as well. So you have the cooling system for the motor and for the battery. So
we were talking about the little battery that goes into the like the car kit. So it's like this little lithium-ion polymer. Yeah. And so this is basically, is it? Do you know? I mean, like I saw the battery, but it was a box. Inside, is there like thousands of these cells, or is it just one really big polymer cell? I'm guessing because the battery is coming from Williams, and they do not spread like about the whole technology. But I think it's like, as I know it from the Formula student teams, it's thousands of these little batteries. Yeah, exactly. Actually, I remember seeing once like an early Tesla like prototype, like a very, very early one, and it was the cylinder cells, you know, the 4/3 cell, like a very early prototype, and it was just welded together in a gigantic, that's what it looks like, look at a battery bank, but it's the soft packet, not the hard shell, because that would make it lighter. Yeah. But it's like, you have to watch the temperature. If they expand, that can be a problem, so you have to like keep them cool. Pressure. Yeah, the temperature of the battery is really like important, because there is quite a small range within it is working properly. So if it starts at 23 degrees and it's going up to maximum 62, and if the temperature is even getting higher, the battery is like shutting down the complete car, and then so you want to get it high because you want to get as much current out, but not so high. Yeah, exactly. And it's really kind of, that's why you have the separate cooling system as well. And if the cars are back in the pit, to cool the battery faster, they even use kind of dry ice. And I saw that. It was kind of cool. You want to see some of these videos?
I have a few videos. You know, on a fun note that people might know, so some cameras, when they start to get too hot, they'll turn off. Same thing, there's a temperature sensor inside there. I had a GoPro where it would just stop working. Really? Because it would be in the sun too long, or I'd use it and the battery would.
Or like, you know, my laptop, like not my laptop, my computer, I have one that where, you know, if you start processing the fan, it speeds up a little bit to try to cool it down. Okay. That's interesting.
Yeah, we have a few videos.
Yeah.
But before we get to the videos, did you want to talk about this pack that we have? Because I have.
Oh yeah.
Yeah, we have this pack.
So this is the project pack that we worked on together. So T-Connectivity, Adafruit, that's us, and DigiKey, these are friends, who distribute a lot of parts for us, and also distribute T-Connectivity parts, lots of them. We wanted to like make a kit that was like themed with this, and so it's not as big as the Formula E, but you can make your own electrical. It's fully electric, by the way, because I know you care about that. It's fully electric, So this is like the little car kit that you can build, and it's fun. You don't even need any soldering tools. I wanted to make it so you could just use a screwdriver to put it together, which I think is kind of like, here's you, hi. So it's got 2 motors, and I heard that the motors for the Formula E, you only get 1 motor, right? Right, exactly. We get 2. They're small, and these are 6-volt motors, draw about an amp, so about 6-watt motors, and then little rubber things, and then again, you know, you drive the back wheels, and you have a front wheel just for balancing. And then there's a battery pack for the motors, and we just use AA batteries. And the reason we use AA batteries is pretty much for the same reason you guys have to cool the lithium-ion batteries. Lithium-ion batteries they are pretty good at driving motors, but you have to kind of be careful of how much current you draw. And we put protection cells on all our lithium-ion batteries. You guys don't, because you have circuitry that manages it. So what we do is we decide, okay, for the motors, we're going to use this AA's, because AA's are high current draw. You can draw like 2 amps out of them. They are pretty safe. You know, you don't have to worry too much about them getting too hot. Low series distance. So that's the battery pack for the motors. And then we have a Feather, which is a little microcontroller with Bluetooth built in. So this is the Bluetooth antenna here. It's even blue. And then you can use our app to control it. So it's kind of like the telemetry. The telemetry data. And then this is the motor driver, so you get 2 motor driver chips here. So you can add even more motors if you want. You can do a 4-wheel drive robot. And then over here we add the T-Connectivity sensor. So this is kind of neat, because I was like, well, we have this breadboard space. So this is a little temperature and humidity sensor. This is one of my favorite sensors, the HTU-21DF. It has a Teflon filter, which is really good. It keeps, because a lot of humidity sensors, they're exposed. And it's a problem because then they get contaminated.
Yeah.
And like people are like, oh, why is my sensor off? So what's neat is this one has a little white thing is the Teflon filter for people watching. Like, what is that? And then this takes temperature and humidity and it sends it over the telemetry. So like over here, I can show my, hold on, let me log into my iPad, start the app. So on the app, so you can see here, it actually gives you the telemetry data live, and then you can also graph it if you want. And so you can have temperature and the humidity. So right now the humidity is 50%, but if we wait, I breathe on it, the humidity went up to 80%. So it's kind of cool. And then the temperature also went up. And then I also added accelerometer. So like if we hit the car really hard, it'll say crash detected. So I put a little crash sensor in as well. Although I guess you could look over. But you know, maybe if you were like racing and you went around the corner.
That's pretty cool.
So you can see the speed. So I kind of tried to mimic as much as I could of what you can build with, like you build with these gigantic multi-million-dollar cars, but a smaller car. And so people can build these own kits themselves. Maybe they can get inspired to become racers, and they can race them.
I think it'd be hard if you want to be an electrical engineer, or mechanical engineer, any type of engineer, and say, well, I want to build cars and get started now, especially if you're like 10. But electric cars you can. Electric
cars you can, yeah. It's like you can build little go-karts and stuff.
Yeah.
So this just teaches you the basics of motor control, and then of course you can build bigger and bigger cars. And you have a car that you modded too.
Yeah.
You want to hold it up?
Yeah.
So we got these 3D printed fairing. I like that you went with purple.
It makes it go faster.
Yeah.
Yeah, definitely.
I like the 3D. I like, and some, we had one person on the show and tell. Bill, he made a wheelchair out of it. So he made the instead of on the out of the side, the 3D printed part went on top, turned into a chair.
Okay, and then we have a few videos. It's accelerometer, position, pressure, and temperature, and it's some of the engineers from TE who work on that. So you want to show some of that?
Yeah, I do.
Okay.
Because I want to talk about these sensors, but start with these videos.
So with the new accelerometer sensor that TE has provided for us to use on the Formula E car, there's a couple of things that we're getting out from that sensor. There is the vehicle dynamic information, so we're measuring the accelerations of the vehicle. Do we need to work with the driver on the racing line? Do we need to work with the engineering team about perhaps a different spring package, a different damper package on the car to maximize the grip from the car? A secondary aspect of this particular accelerometer, and this is unique to Formula E, is that we actually use it for crash detection. So because it's measuring accelerations, or usually in a crash a deceleration, if we see a peak above a certain value, say above 15 G, which is beyond where a car would ever normally go under normal operating conditions, even a racing car, we can deduce that that is an event that's occurred usually because of a crash. And then that would then interact with some safety systems on the car, and then would actually put the car into a safe state. So when the safety workers come to the car's not potentially at a high voltage and could cause further injury to an innocent party. So we have some position sensors on the car, and the TE sensors are actually on the rear suspension. So what we do with those is the wheel moves up and down, we're able to measure the deflection of the spring and the damper unit, and we can look at, if that position sensor is reaching its max value, that probably indicates the suspension has reached the limit of its travel. We can look at the rate at which that sensor is moving. So if we see it move very, very quickly, that indicates that we've hit a bump. We do quite a lot of post-processing on those signals. So from that information, we've hit a bump, we know the acceleration rate or the velocity of that sensor. From that we can then look at the damper curves that we have on the car and say, are we operating in the right range? For example, if we see a suspension velocity over 200 millimeters per second, we can look at how much damping we've got in at that velocity on the damper and say, okay, we need to make an adjustment here to help the car ride the bump better. So that there's a lot of information that comes from it. We can also look at what happens to the suspension or the car as it's traveling at high speed, We know the faster we go because we generate downforce. It presses the car down towards the racetrack. We can look at the ride height change of the car as it goes down the straight. Are we getting into a situation where we might actually touch at the end of the straight, which could unsettle the car when the driver goes into the braking zone? That might lead to a decision that we need to, say, raise the front ride height to keep the car off the ground. So it's for what is quite a simple technology within this displacement sensor, it actually gives us a lot of very useful information, and that information comes from the post-processing that we do on the signal that the sensor sends out.
We have put a lot of new sensor technology into the car. We're monitoring various different pressures, temperatures, accelerations, and by doing that, we're able to better monitor the car on the track to not only help the driver, but to actually push the development of the car.
Pressure sensing usually is used for reliability aspects of the car. You're monitoring the health of the various systems on the car. So for example, we have a pressure sensor from TE on the gearbox, and what we're measuring is gearbox oil pressure inside the gallery. Now that would indicate the health of the gearbox. If we've always got good oil pressure, just like on an engine, the gearbox is going to be healthy. Now we could start to see dropouts. Dropouts could come because we're cornering, we've got a high G corner, the oil's moving inside the gearbox, it's maybe moving inside the oil tank, we're exposing the pickup and it's sucking air rather than sucking oil. So we would get a period of where the pressure would drop out. A decision could be, actually we need to add another 100 millilitres of oil to the gearbox just to ensure that the pickup's always covered up. It could indicate that perhaps there's something going wrong inside the gearbox. I mean, typically pressure is linked to temperature. So as the temperature of the gearbox rises, we would typically see the pressure drop a little bit. We could see that if we got extreme temperatures, that maybe the pressure drops too low. If we're not getting sufficient pressure in certain aspects of the gearbox or certain areas, we could be losing the lubrication capability, which could then leave a bearing to fail or something like that. So typically we would use a pressure sensor for more reliability related stuff as opposed to performance. On the car we have a temperature sensor which has come from TE. This particular application we use to measure gearbox temperature, and again it's primarily used for reliability, but it does have some performance aspects to it. As you may know, oil viscosity changes with temperature. So as the temperature rises, the viscosity changes, it gets thinner, and typically in a racing environment that means a little bit more performance. So for example, in qualifying, where we just have one lap, we want the most performance we can get from the car, so we'd like to see the temperature come up quite quickly. However, if we had the temperature come up too quickly in the race, the likelihood is when we get to towards the end of the race, temperatures would be extremely high, and this could then lead to compromising the integrity of the gearbox. Maybe we would see a bearing failure, or we would see the oil film thickness between the gears break down, and that would lead to wear on the gears. So you know, we spend a lot of time monitoring what's going on with temperature sensors. Typically we don't use them in a control environment, which means the signal is passive. We look at it, we record what's going on, but we're not using it as an input into another strategy, certainly in this particular case.
Okay. That was like the voice of the internal. Okay, so thankfully, the nice people explain the sensors, but we actually have these sensors. That's why they did all the talking about what they are. So let's actually look at them. Want to do that?
Yes.
Okay, that's cool. So what is this?
This is an accelerometer. I think this is the one which been in the car like in the first season. Yeah. As we already have like the one of season 2 and 3 with us, we can see the development even from the outside.
So this looks like it's a single axis. They start with a single axis accelerometer, and then this is the next gen.
That's the next generation,
yeah.
right?
Okay, so 4630, that's bigger than 4604.
Yeah.
And so this one Oh, and they've got codes. Is this like a date code or a work code, or what is that?
That's actually like serial numbers.
Okay, so you know, like if this one, yes, this one's got the serial number.
This one has free access.
Yes, this is X, Y, and Z measure.
Exactly.
And it's got like these nice bolt hole. I was kind of wanted to open this, but it's like it's glued shut, and I was like, I'll probably get in trouble. But is it analog output or digital? What kind of connection do you have for the I2C or SPI? Do you know?
Good question.
Yeah, I don't know. It just plugs into your data acquisition system. It's probably analog because that way you get like your digital acquisition system can be as high resolution as possible. Okay, so you got this, and then this is, you think is the next gen?
Yeah, this is the really new generation, which is going into the development test cars so far. So this is really kind of brand new.
Oh wow, this one has on the cable says 3-axis accelerometer.
Yep, and it's going up to 50G. So yeah, it's providing informations. Just to give an example, like the car was crash or something, you would see in all different axes.
But also like if it vibrates too much, you would know that. Or if what I thought was interesting is he said you actually do Z-axis measurement to see if it's a lifting or pressing down into the
I got a question
concrete,
from the chat. I'll try to sprinkle some of these in here. So in regular cars that some of us can drive, there is a protocol for the sensor information to go around. I guess it's CAN bus or something like that.
Yeah.
What's used in Formula One is it, Formula E. What's used its own thing, or do they use some?
I think it's also like in the standard car.
Gotcha.
Yeah. But it's just like their own sensors. But the sensors are more intense. Like you don't get a 50G accelerometer in your everyday electrical or even gas vehicle. But so this is and I have a question. So one of the things that I saw in the videos is that the way the Formula E works is everyone's got the same chassis.
Exactly.
And then and it sounds like everyone gets the same battery and motor as well. And then it's everything
else.
Not the motor. The motor you can make your own.
The motor is for this season. They got you the possibility that you develop your own motor now.
But that's new.
That's new, right? And they will open like the whole powertrain system up to season 5 as well, so that more development can start and go on.
Oh, so they basically want to start like everyone's fair. You get pretty much the same thing.
Exactly.
But the sensing system is completely up to everybody. Everyone who's racing has their own sensors.
Kind of. There are quite a lot of sensors which are like also specified by the FIA and so on, like wheel speed sensors and so on. So you have like a huge of reglement, which is provided by the FIA, how in the mandatory things the car needs to look like. But there are some spaces where you can at these things, and I think this accelerometer is like only within the car of Andretti.
Okay, that's cool. All right, so here's the real question I wanted to know is, do you, as you know, because you're working on Andretti Motorsports, do you as the like engineer that working on the car ask TE for the sensor? Like, can you ask them to make you a sensor of the specific? Like, if you're like, oh, I need a 100G. I don't know why, but you need a 100G. Could you go to them and say, I want a special sensor?
This one here is really kind of developed together with Andretti Technologies, especially for their need. Yeah. So, I or my successor or former engineers really went there and said like, okay, Andretti has this special need. We need to develop something.
Okay. Wow, that's cool. All right. So you guys have like. And you only get to use it like once, right? But you get
it probably trickles into product development at some point because, like,
exactly.
well, if we need this, someone else is going to need
this. It's in the product portfolio so far, so you have it in a magazine and you can buy it.
Okay, so this is the next sensor, and this you said was it's a pressure sensor, so it screws in, and there's a little O-ring here, and then this measures the pressure where?
That's for the gearbox actually. So you have like oil in the gearbox, so it's really kind of important to know how the pressure is there.
So it's like a hole, and then there's some piezo or something that I don't know. I don't actually know what's in here. I'll find out. And is this like a standard sensor too, or is this a custom made one?
That's a standard one as well. Yeah.
And then what I like is that you have these really nice Teflon coated wires. Yeah. They're hard to work with, but like you have to have the temp. I mean, what is the temperature inside of the engine? Like, what does this have to
inside? On the motor?
It's on the surface.
Good question.
Hot.
I'm not
very hot. Really
very hot.
Okay. No, worth asking.
Hot enough for Teflon.
Yeah, you need Teflon wires. And then here's another sensor. And so I think
that's like a temperature sensor.
Yeah, this one actually I saw. This was the data sheet. This has a calibration document.
Is it?
Yeah, they came with a calibration document. So this is a certificate of calibration. So it's measurement specialties, and then it gives the part number and a serial number. which is probably written on here somewhere, etched into it. And then it's a platinum resistance thermometer. So these are really neat. Have you ever used these before?
This one in person? No.
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 I have. No, because I'm just like, I just actually like, I'm like, finally, there's something I know. So there's a little piece of platinum inside. It's a very thin strip. And platinum, we've really defined the resistance over temperature. And so the resistance of it, this is a PT 1000 because it's 1000 approximately at 0, but you can see that it's actually not. It's like depending on impurities or the length, it can be slightly different, so it has to be calibrated so that you have a really precise like resistor meter.
Yep, exactly.
And it can measure, it actually does vary quite a bit, but it's like super precise, and so it's like within 0.1 degrees C. So this is like pretty intense. So this is, what do you think this measures?
The temperature?
Yeah.
Could be like for the battery, for example, but also, what else was it? Like you need temperature, oil as well, like for brake fluid and so on. Yeah, so different ways of using temperature sensors.
Yeah, one of the things that was in the videos is the person said that, you said you take all these measurements, and you have these like super intense calibrated measurements, and you said the data is stored and then analyzed later. I mean, some of it must be used during the race, but is it the driver is just too busy, they can't do it, or you don't have a computer? How does it work?
You check during the race. There's like, you need to check like the energy management of the car. So each driver needs to hit like a certain or special number during each lap, and it's in constant talk with the engineer. And this is really important for, as I said, for the energy management and also for the region they have. So that's something you can check during a race. And every engineer has his certain kind of data which he's checking and taking care of. Yeah.
So you're accelerometer lady. You're like, you said you do the
I am the connector and sensor lady from TE.
Wizard.
Yeah.
Okay. And then, all right, so this is some cool. What's interesting is that, when we said we were going to do this, I said, I want y'all to send me some sensors. And they're like, what? And I'm like, yeah, we're going to turn them on. And they're like, okay, we weren't expecting that. And then we had one more. Oh, yeah, so this is the fourth one. And so this is the one that was actually in that first video. And so we were looking at this. So this is
a position sensor.
It's a position sensor. Yeah. It kind of feels like, it's interesting if you feel it. It's like, it's really smooth.
Yeah, it's like, it reminds me, and I think it's also placed like at the steering of the car. So somewhere at the wishbones, I guess.
It feels
really
like it's a hydraulic thing.
Yeah,
but it's not. Yeah. It feels like it's like a hydraulic piston to dampen, but it's actually not. It's a potentiometer, and there's like 3 wires, so it's plus, minus, and signal, and then this is just a really good potentiometer. And what's interesting is like, I don't even want to know how much this costs because it's a lot. A lot of the things that people engineers ask is like, well, we sell, for example, like maybe a potentiometer like this. And people are like, oh, can you use this in racing or like automotive? And I say, no, this is not specified for automotive use. Yeah. And so, and that's kind of interesting because we have a lot of makers, and the makers are like, they're building like these little like mini robot cars. Hi, and so your parts don't have to be specified that intensely, but when you when you're working on stuff, you have to have the specifications like really worked out.
Yeah,
like
exactly.
And then do you have to replace the sensors after each run, or is it like, oh, this has a lifetime of 1,000 hours?
No, so these things are like in automotive, as you said, it needs to be specified in a special way. And what we are doing is this kind of cars, or this race cars, are the harshest environment where you can test your products, but we also test the products within our test competence centers we have. So they really go into like a huge fridge actually, or temperature box, and they go down to minus 40 degrees.
Like I'm sure they just have a machine that all it does is go like this
exactly
all day and like vibrates it and just sees like is the measurement coming out.
Exactly.
Right? So that, because I can imagine like what's interesting is like this, like I'm not worried about this. Like this isn't a cube.
Yeah.
Like this is fine. And even these temperature sensors, like there's no moving parts.
Yeah.
The moment you have something moving and it's like vibrating and it's shifting and it's getting twisted and torqued.
You stress these things out in the test competence center and see how many moves it can like survive.
Yeah.
Definitely.
Okay,
yeah.
so this is the most, and it's kind of a nice green color too. Okay, so those are the sensors that I brought. Is there any other sensors that you use that we don't have that you are your favorite sensors?
My favorite sensors in the car and yeah, the accelerometers definitely.
You like those?
Yeah.
And how do you test them? Do you actually do you have do you hit them against the wall? Like how do you know that they work? I mean,
they have like special machines to test it and to destroy these things. Actually,
what's the machine look like?
Like, oh gosh, like a huge metal thing is falling down of the accelerometer.
Oh, it's like this drop of gigantic lead thing on
exactly,
it. Okay.
Exactly.
That's cool. Yeah. And so then, so you test them, and then do you know, is it like a MEMS accelerometer? I mean, I kind of imagine it has to be. Or do you know what the technology inside is? I don't know. It's probably a MEMS or something, but it's just like really big, so it can do 50. You said 50 Gs?
It's 50 Gs. Yeah.
Jeez, that's a lot. And how many Gs does it normally get to in a car?
Like in a car. I think you say a normal person is passing out at 8 to 9 Gs.
Okay, so wait, why does it need to be 50 then?
Well, that was the question from the chat room is like how many Gs are these things?
Because the thing is, if there is an accident and the car is maybe like flipping or over-rolling or something, you have really high forces which are like coming to your body and the persons are still survive. I heard there was an accident with a race car like some weeks ago. And they recognized the driver was forced like to have like with 120 Gs and he survived.
Wow.
But the forces which are like using to your body and with your belts and so on really, really high.
Okay, so that's why everybody 50 Gs when you do your race car. Okay. Whew. It's pretty intense.
Okay, let's do some questions. There were some in the chat. Keep it to race car questions.
Yeah, you have a question about sensors or accelerometers or T sensors, humidity sensors.
So let's get started.
Or if you want to know how you get into engineering and designing.
Yeah, that was actually one of these. So Judith, someone wants to know what got you started. What was usually someone has a story or a project they did when they were young and they said that's why I want to become an engineer. Do you?
Started with I was also always interested in race cars and technical stuff since I was actually a small kid. And after I graduated, I've been to England as an au pair. And after I came back to Germany, I thought like, okay, what am I going to do now? And I did an internship at the really huge airplane company in Germany. And then I decided like, oh, that's actually a thing I'm interested in. And like all the cables and wires are going through that airplane and then how an airplane is like,
flying computer.
Flying,
and you have a racing computer.
And it's like flying. I heard like the amount of wires in a plane is like a quarter of the weight or something. I mean, there's so much wiring.
It's incredible. You have like wiring through a plane like up to 50 kilometers. That's really unbelievable. And then I decided to study mechanical engineering, and so I did.
Oh wow.
Oh neat.
And then as far as the rest of the Formula E Tour, so New York is the current stop. That's this weekend.
Exactly.
And then, do you know what your schedule is? What are the other Formula E's that you're going to be
at? The last race for the season is then like 2 weeks later. It's Montreal.
Okay, so that's where you're next.
Yeah.
Gotcha.
And then every season you get to do more because there's just more sensors and more technology and like more battery.
Possibly, yeah.
So there's actually it's more exciting in the future. I like that. It's like you don't like every year. It's not like same old. Every year you have to update it. Like you're excited about. You've always talked about racing. About what you like in racing is that the previous year, like every year, you have to start from the beginning. The competition is intense.
Yeah.
Okay. And how does the TE racing team do? Pretty good.
It's okay at the moment.
Okay. Yeah. Okay. All right. More
okay.
sensors.
Next question. How does someone get an engineering job at a company where they get to be hands-on? It sounds like you're pretty hands-on.
How do you get an engineering job there? Yeah, I just applied for the job. That's it.
Yeah. I think we're on the show and telling, releasing projects and showing you want to get your hands dirty. Okay. And then here's another question. It's more like where you can put some of these sensors. Can you install an anti-crash type sensor or is that strictly up to the driver's eye? Like, is there anything you can install so it avoids like collision detection, or is that not for race cars because it's all about the person? Like,
I'm not sure because like this season is really like, or this series is really restricted at the moment by the FIA. So not sure about.
Yeah, it sounds like which I think is interesting to make it fair as possible.
Yeah,
they're
exactly.
like, you can't have a sensor that affects the steering wheel. Steering wheel has to be under human control. However, you do have to have a temperature sensor for the battery pack for safety and you know, efficiency. So I think that's a good thing to say, like, look, you know, you have to have this level of professionalism and technology, and then here's the things you can mess with. You can mess with sensors, and you can change your, you know, how many gears you have. Like, that's new also, but you can't like redesign the whole car to be like autonomous car.
Okay, next question. Do you know if there's any sensors on the driver, like heart rate or like any bio sensors yet?
Not as far as I know, but if he wants to, if a driver wants to have it, I'm sure he can do it by itself.
Like a Fitbit?
It'd be cool to know just like how calm or how excited they are. Yeah, it's like either someone is just like, no big deal. So I want to know how fast are the cars compared to regular cars?
These cars go up a maximum speed to 140 miles per hour, which is like 225 kilometers. So that's the top maximum speed.
Okay, but full electric, that's the deal.
Yeah, that's the
deal. So the acceleration is a lot faster. Like they can
because you have like the power and the torque right from the beginning. That's completely different compared to a combustion engine.
But you can't get as much RPMs.
You can step on the gas immediately, but that will and stay on the gas, but that definitely affects like the power of your battery.
And what's the challenge of these cars? Like, is it the challenge like the battery management, is it temperature management? What's the thing that people are like, this is the
real challenge is like to find the balance to be quick and of the battery management. So really kind of like a good steady balance that and also that you use your region pretty well during a race. So that's really the challenge with these cars.
Yeah, too fast, too hot.
Exactly.
Bad, too slow, lose the race. Got to be in the middle.
Exactly.
Okay, that's hard.
There's some folks working on electric bikes and they're like, this is useful. Good to know. Do you know if the Formula E folks have looked at or considering those heads-up displays on the helmets or anything where they get like little data, or is it all like dash-based and
yeah,
at the moment everything or every information the driver needs is going through like the team radio and some even to his steering wheel.
Gotcha.
So he can swap pages during his driving.
I imagine if you're driving that fast, you can't actually look at the gauges. I mean, your vision is very...
Is it pedal steering? Is it pedal shifting? Is there gears?
Yeah.
Oh, so it's the same, it's paddle, the same thing as, so you're doing the shifting of gears, which is a different... Gear is different, I guess, for electric,
right? Do. No, you have a transmission with gears. You can also control the speed of the motor, but I was reading about it, it's kind of interesting, because I'm wondering about, like, how, you know, do you have gears? The motor runs, you know, there's an optimal RPM for the motor, right? Like these, they run, there's a gearbox inside of here, so you have the motor, and you want to run it at the optimum speed for, like, the power and torque, and there is, like, a perfect spot. And then you have a transmission, like a standard hydraulic transmission to convert that. Yeah, I was like, that's kind of neat. But you don't have to, right?
You don't have to, but it's really good to get like the optimum, as you said, for the car. So.
And who makes the motors? Do you know who makes these motors?
The motors at the Andretti cars is an own development by Andretti Technologies.
Oh, so this is the first year because they can make their own. They're like, we're going to make our own. Have you gotten to see? Is it like just like a gigantic coil? Like what's?
I haven't seen it
Maybe
so far.
That's
like really internal technology.
Shh. Look at it.
Yeah. Well, I remember reading about Formula One racing where they eventually let whatever team won a couple of years later retire out the engine to a team who wants to get into like the top 10. So maybe it'll be like that one day, where it's like.
I mean, that's it. I think this. I mean, it's interesting because like Andretti Motorsports, is this like, have they done a lot of electric car stuff before? Or is this like their first?
I think that's the first.
This is their first. So they're like.
This is smart.
It's like
the other cars they have is like for sure the Indy cars, the Indy Light cars, and the Rallycross cars.
Yeah.
Yeah, and the Formula E cars.
Yeah, it'll be interesting to see if like you know, as we've said, like there's a lot of companies now, American car companies, European car companies, all getting into electric cars, and yeah, like how far they can go on the battery is the most important thing, right? That's like that's their difficulty is you have a battery, and it's not how fast it charges even, it's just like how far can you go. So they're going to have that same, you know, it doesn't have to go as fast, but they're going to have the same kind of issues. It'll be interesting if the technologies from Andretti and TE end up informing and helping our domestic cars.
Exactly.
Vroom, vroom, 140 miles per hour.
Okay. We're going to do a couple last things. We're going to give some away. We're also going... Oh, those are the questions. Thank you. Thank you.
Thank you.
Thank you.
All right. Those are the questions.
I did a little bit of research ahead of time.
Yeah. Okay. Next up, just a reminder, the code is DigiKey all the way to 11:59 p.m. And Lady Ada, we're going to first give Judith a present. This is for you. It has stuff in it, yeah.
It's got all these cool badges and stickers and stuff.
That's cool. Thank
so
you.
It has a lot of stuff. Thanks for being on the show. Here's a copy of me as well.
Yeah.
Here you go.
We have 3,000 of these.
Every contestant gets turtle wax.
That's a great picture.
Yeah.
So,
that's really cool.
Now we're going to give something away, and we do something neat. What we do is we let people call us on this payphone over here. It's a payphone we modified. And what do you want to give away this week?
We're going to give away one of these TE My Mini Race Car kits. You can build your own race car kit. This is awesome. This is the fanciest prize ever. It comes with motor, chassis, feather, motor shields, robot parts, everything you need to build your own robot.
Okay. What are the rules?
Rules are, if you've won something before, please let someone else win. We want everyone to have a chance to get the prize, so please hold on to your hats. Okay. The first person to call the phone number, we're going to ask you your name and where you're calling from, and then tell us what you're working on, what you want to work on, and we'll send you out this wonderful box.
Yeah.
So call this number.
The phone lines are open. First caller.
Call this number. I'm going to ask you your name, where you're calling from, something you're building.
Yeah. Let's see who calls first.
Go for it.
So it works. It always surprises works, yeah.
Okay,
all right,
hold on.
Go for it.
Hello, you've reached Ask Engineer. You're the winner. What's your name and where are you calling from?
Hi, it's VJ Pussycat.
Hello.
You won.
Congratulations, Mr. Cat, Mrs. Cat. What's your full name again?
I'm Jamie.
Oh, Jamie, okay. Oh, sorry, I thought you said you're like Mr. Cat, and I'm like, okay, that's cool.
No.
Congratulations, you are the winner. Can you tell us where you're located and a project that you're working on?
Well, I'm in Reno, and I have lots of projects I'm always working on, but right now I happen to be working on the motor system with my bicycle. I was saying in the Discord room, I've had to make many repairs to this, but I've found that my current problem with it is a sensor in the throttle, and I don't really know anything about this stuff. But I'm finding this show to be very applicable and interesting in this matter.
That's cool. You're making an electric bicycle. All right. Well, congratulations. We're going to send you a robot. All you have to do is email support@adafruit.com and say your name, Jamie from the chat, and then email support@adafruit, and we will mail you out physically this robot, and you can build it while you're working on your bicycle.
Awesome. Thank you so much.
Okay. Well, thank you so much.
My bike.
Oh, sorry. What did you say?
Sure. My bike does have show and tell stickers on it, by the way.
Oh, cool. Yes. Well, now you're going to have even more stickers. Actually, this kit also comes with a cool pin, so you'll have that too.
Oh, nice.
All right. All right. Well, thank you so much for calling.
Well, thank you. I love you guys.
Okay. Have a good night. Bye-bye.
All right.
They're working on a motorized bicycle. And they're like they have throttle sensors and stuff. So.
For the folks who didn't get a chance to call, that's okay. You can leave us nice voicemail messages. Sometimes we play them on the show.
Okay.
Yeah. Okay. Well, that's the show for tonight. Thank you so much, Judith. Thanks for coming by.
You're welcome.
Next time,
you said 2 hours.
Next time you have an electric car race that you're in town for, let us know.
Yes,
I will.
We'll be there tomorrow.
Let any of the other T engineers, they can come on and show and tell. They can stop by.
Exactly.
And you can take these sensors. No, just kidding.
Yeah. And that's it for tonight. We'll be filming.
To make him a nice necklace or something.
We're going to be going to the races. We were never really interested in car races because we don't drive, but electric cars, that's all the stuff that we like to make and build its batteries, its stuff. So this is interesting for us. Finally.
That's cool.
Yay, a sport
yeah, and I want to like look at these.
A sport that we can.
I want to look inside. We're gonna like learn. Now that I've studied all about it, I'm gonna check out this car.
Yeah.
And see what's up.
Well, don't forget the code, everyone. Thank you, everyone at Adafruit, all the folks working behind the scenes tonight, all the folks that were at Adafruit today, TE crew, DigiKey, and TE, and everyone else. We'll be here next week, same time, same place. And I always have to remember, here's a picture of our cat. We have a cat. And when we had an apartment, we used to show the cat when Adafruit was just an apartment, but now we can't have a cat here. Obviously. It's Mosfet the cat.
Meow.
I have to remember it's Mosfet the cat. I can't just say cat, he has a name. And to play us out tonight, I'm going to play one of the videos I saw in TE that I really like. It's interviews with people, women who work at TE, because it's a technology company, and some interviews with them. So I thought that was, and by the way, no one asked me to do this. I just thought, no, really, like this is like, oh, cool, I can play stuff from your YouTube channel. So I just grabbed this. I thought it was neat because there's a lot of women and young girls that watch the show, and they could see the type of company and the type of things they might work on. That's really good. Yeah,
and if they're like, I wonder if I can grow up and like work on race cars, the answer is yes.
Yeah,
you
Definitely,
can.
you can.
We have proof here that it's possible, and you can travel the world and hang out with racers, but you don't actually have to do the racing, which seems really stressful. I mean, maybe you want to, but you don't have to. You just work on the car, and it's like you get all the joy of the technical noodling, and you don't have to like sit there and actually race the thing.
Yep.
Yeah.
Somebody else does that.
Yeah.
I don't like driving, so
yeah, you get car sick just going around the block. So.
Yeah, I can't even.
But you want to make the sensors out. So.
I will totally design an electric car if I don't have to drive it. I don't want to drive it.
Okay, so we're going to play that video, but first, here's your Mona Maziner. Hi, everybody.
Good night. Good night.
The best thing about being an engineer is the ability to take my curiosity and form that into problem solving for our manufacturing.
Engineering, I think, is one of the highest expressions of being able to find purpose in your job. And so if you want to contribute in a meaningful way, you know, right out of school as a graduate engineer, you can do that.
I decided to join TE because when I interviewed here, I could really tell that the leaders were interested in hearing what I had to say and the ideas that I had, and that I would be able to do something great here and really add value.
I think one of the things that women bring to the table at TE is creativity and compassion, openness to new ideas, and a passion for problem solving that helps make our products some of the best in the world.
What excites me most about working at TE is being part of a company that enables real and life-changing innovation that touches every aspect of our lives, from the cars that we drive, to the appliances in our homes, to the factories we work in.
We're a global company. We have numerous business units. So you can look across regions and find a region that works for you. You can find a business unit that works for you. And you can move across regions and across business units.
The company has endless tools, whether that be employee resource groups, development learning, networking opportunities.
I think in a lot of other big companies, you're kind of put into a project and you're lost in the system. Here, you come here and people will listen to you. You'll get put on a team right away. People will listen to your ideas and just embrace what you have to offer.
To be able to be myself and bring my full self to work and know that that's embraced and valued here keeps me engaged and passionate about the work I do every day.
It's vitally important to have diverse perspectives and a diverse workforce. We could not be successful if we did not do that. We would fail to be innovative. We would fail to come up with solutions to new problems.
Our tagline is every connection counts, and I can tell you at TE, that's more than a tagline. It drives everything we do, whether it be interaction with our employees, making those connections, and more importantly, connections with our customers, because that drives everything we do.
There's the opportunity to be a part of so many different teams and build different networks. There's women's networks, there's young professional networks, there are functional networks like marketing councils and product councils. So you have the ability to create this community around you.
The Women's Network at TE is a fantastic organization. It's giving all kinds of women at different levels in the organization an opportunity to lead.
One of the things that we focused on is what we call the PI concept, and it's all around performance, image, and exposure. We're really trying to help our women advance their careers at TE.
Every connection really does count. You can't do a job individually by yourself. It really does require a team. And having the global community around you in terms of the support that you get whether it's in China or India or Brazil or the US, you need to rely on that team of folks to help you in your role and how you drive results for TE.
We sponsor the Andretti Formula E team, and that's one of the things I do here at TE. I manage that sponsorship. We host customers and hospitality events. We travel all around the world hosting customers to gain mind share with those customers and make the TE brand more favorable.
Whether it's that we have parts that were on the Juno spacecraft or our partnership with the Franklin Institute and Pixar, it's an energizing company with something going on all the time.
Everything is so connected in the world today, so it's really exciting for an engineer to be on top of that and be a part of that.
I'm energized. I'm energized because we help engineers build smarter machines that serve the world's needs. I'm energized because I get to work with amazing people all over the world every day. And I'm energized when I see a rising generation of women leaders lean into the challenges that we have as a company head on.